Nitromethane can also be used as a monopropellant, that is a fuel that burns without added oxygen. The following equations describe this process. 2CH3NO2, it gives 2CO plus 2H2O plus H2 plus N2. Nitromethane has a laminar combustion velocity of approximately 0.5 meter per second, somewhat higher than the gasoline, and thus making it suitable for high speed engines. It also has a somewhat higher flame temperature of about 2400 degree centigrade temperature. The high heat of evaporation of 0.56 millijoule per kg together with the high fuel flow provides significant cooling of the incoming charge, which is about twice that of methanol, resulting in reasonably low temperatures. Nitromethane is usually used with rich air fuel mixtures because it provides power even in the absence of atmospheric oxygen. When rich air or fuel mixtures are used, hydrogen and carbon monoxide are two of the combustion products. These gases often ignite, sometimes spectacularly, as normally very rich mixtures of the still burning fuels exist in the exhaust ports. Very rich mixtures are necessary to reduce the temperature of combustion chamber hot parts in order to control the pre-ignition and subsequent detonation. Operational details depends on the particular mixture and engine characteristics. A small amount of hydrogen blended in nitromethane can increase the power output even further. With nitromethane, hydrogen forms an explosive salt that is again a monopropellant. This unstable mixture possesses a severe safety hazard and is forbidden for use in model aircraft fuels. In model aircraft and car glow fuels, the primary ingredients is generally methanol and with some amount of nitromethane, that is 0% to 65%, but rarely 30%, since nitromethane is expensive compared to the methanol, and 10 to 20% lubricants, usually castor oil or synthetic oil. Even moderate amount of nitromethane tends to increase the power created by the engine, as the limiting factor is often the air intake, making the engine easier to tune, adjust for the proper air-fuel ratio. Next, the explosive properties. Nitromethane was not known to be high explosive until a railroad tanker car loaded with it exploded on June 1st, 1958. After much testing, it was realized that nitromethane was a more energetic high explosive than TNT, although TNT has a higher velocity of detonation and brisance. Both of these explosives are oxygen poor. And some benefits are gained from mixing with an oxidizer, such as ammonium nitrate. Pure nitromethane is an insensitive explosive with a VOD of approximately 6,400 meter per second, that is 21,000 feet per second. But even so, inhibitors may be used to reduce the hazards. The tank car explosion was speculated to be due to adiabatic compression, a hazard common to all liquid explosives. This is when small entrained air bubbles compress and superheat with rapid rises in pressure. It was thought that an operator rapidly snapped shut a valve, creating a hammerlock pressure surge. Nitromethane can be sensitized by adding a base to raise the pH. Nitromethane can also be mixed with ammonium nitrate, which is used as an oxidizer to form an explosive mixture known as ANNM. One graphic example was the use of nitromethane and ammonium nitrate in the Oklahoma City bombing. It is also miscible with concentrated nitric acid, forming an explosive composition with similar power and sensitivity to nitroglycerin. Purification. Nitromethane is a popular solvent in organic and electroanalytical chemistry. It can be purified by cooling below its freezing point, washing the solid with cold diethyl ether followed by the distillation. Uses. The principal use of nitromethane is as a stabilizer for chlorinated solvents, which are used in dry cleaning, semiconductor processing and degreasing. It is also used most effectively as a solvent for dissolving agents for acrylate monomers such as cyanoacrylates, more commonly known as superglue.